Choosing a goal and sticking to it changes everything. Hello everyone, my name is Hussain. This is the last video in carbon and its compounds. In this video we are going to discuss what is soap and cleaning action of soap. How soaps can clean dirt from the dirty clothes. Okay. First we will see what is soap. Before going to that, in last videos we have discussed about saponification reaction. How soaps are formed. How soaps are formed. For example, if you take any ester or COOR, this is the general formula of ester. So in the previous video we have discussed about an ester CH3COOC2H5. What is this name? Ethyl acetate. So this is a simple example. Ethyl acetate is an ester. Ethyl acetate. When esters are reacted with concentrated acids, concentrated bases, sodium hydroxide for example, will get CH3COO minus C2H5 plus, Na plus and OH minus, and the CH3COO minus combines with Na plus will get CH3COO Na. This is called sodium acetate. And similarly the C2H5 plus combines with OH minus will get C2H5OH. But these are of the simple compounds. Actually soaps are formed by the higher fatty acids. For example, if you take stearic acid, the formula of stearic acid is C17H35 COOH. This is called stearic acid. When stearic acid is treated with NaOH, sodium hydroxide, then we'll get sodium stearate C17H35 COO minus H plus and Na plus OH minus will get a salt C17H35 COO Na. This is called sodium stearate. This is sodium acetate. Sodium acetate. This is a sodium stearate C17H35 COO Na. Sodium stearate will be formed and H2O. Sodium stearate is one of the best example or simple example for soap. Soap is also called sodium stearate or potassium stearate, and its formula is C17H35 COO Na. When the soap is dissolved in water, for example C17H35 COO Na, when it is dissolved in water, it splits into ions. It splits into C17H35 minus and Na plus ions. C17H35 COO minus and Na plus. So it splits into two ions. This is called stearate ion. This stearate ion has two parts. One is C17H35. If you expand this structure C17H35, we will have total 17 carbons. See, starting from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. Total 17 carbons, and at the end COO minus. This is the actual structure. At each corner there will be CH2, 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 and if you continue to write this, and you will get the actual number of carbons and hydrogens in a C17H35. So at each corner there is a CH2 group. Okay, in the beginning there will be CH3. Here there is a CH3. This is the actual expanded form of stearate ion. Every time writing this huge structure is difficult, so simply we can take it as we can simply represent this as like this. Okay, this is minus, that is COO minus part, hydrocarbon part. Actually this hydrocarbon part is a non-polar part. This hydrocarbon part is non-polar part, and this head part, this part is the front part, COO part is a polar part. Polar part. It looks like a snake, and this is the head of the snake, this is the tail of the snake. The head part is polar, whereas tail is non-polar part. That means the stearate ion is having polar and non-polar parts. Okay, this is briefly about the soap formula and its structure and different parts of the soap, polar and non-polar part. Now we will discuss how this clean the dirt from the clothes. What is dirt? What is dirt? In most of the cases, dirt is a greasy part or oily part. Most of the dirt is in oil form, greasy form, which is non-polar. Greasy part is non-polar part because that includes many hydrocarbons. Generally, non-polar part combines with non-polar. So let's take an example. Let's take a vessel in which some soap or detergent is added, and soap or detergent will have this stearate ions, that is polar and non-polar parts. When to this soap solution, when you add some dirty cloth, the dirty cloth will have some greasy part. Means dirt is a form of oil or grease, no? It will have some greasy part. This greasy part within the cloth is surrounded by the non-polar part of the soap, that is stearate ion, because non-polar part combines with non-polar. That is, it is also called hydrophobic part. Means hydro means water, phobic means which is repulsive with water, which do not dissolve in water. The grease also hydrophobic, and this non-polar part also hydrophobic. So the hydrophobic part of the soap combines with this greasy part. Hydrophobic part combines with the greasy part, and it surrounds the greasy part. All the tail parts of this stearate ion combines with that greasy part and will get a very big molecule, and this is called micelle. A micelle is formed, and when the micelle is formed and it stabilizes the greasy part, this micelle stabilizes the greasy part present in the cloth. That means this micelle doesn't spread the greasy part or the dirt part within the cloth, and it fixes it and stabilizes it. This head part will be in the combination. This head part will be in the combination with water, because the head part is a polar part. It combines with polar water. Water is a polar solvent, no? Water is polar in nature, no? So water combines with this polar part. So this is how a micelle is formed. That means the head part of the stearate ion or soap ion is combined with water molecules, whereas the grease within the cloth is surrounded by the tail part of the soap, that is non-polar part. This is how a big micelle will be formed. This micelle stabilizes the dirt within the cloth. So when you remove the cloth and move your hand over the cloth, then head part along with the tail part and the grease part, everything will come out. This is a very simple magic. So when you move your hand over the cloth, which is already soaked in detergent or soap, then head part, tail part, and the tail part is already in connection with association with this grease part, and everything will come out and the cloth will be free from the dirt. This is the simple cleaning action of soap. I hope you understand this concept, that is the cleaning action of soap. Before going to know the cleaning action of soap, we should know what is soap and what is this formula, briefly about its structure. Actually, soap is having two parts, head part and tail part. The head part is a polar part, and which will be in combination with water molecules. The tail part is non-polar part, which forms a micelle by combining with a greasy part or a dirt part on the cloth. Dear friends, I hope you understood this concept, and support my channel with your subscription and share these videos to your friends. And this is the 5th video. Go through all these videos, practice well, and go through your textbook also, and try to answer all the questions given at the end of your textbook.